So we're going to do a quick warm-up first. We have a triangle. DOG is congruent to triangle ARF. I want you to identify all the congruent angles and congruent sides. So I wanted to show you that if you want to do that, you're going to write angle D and angle A. They are the first letters. Those are congruent to each other. They're corresponding. O and R are congruent to each other. G and F is congruent to each other. So you can actually draw a triangle. And when you do sides, you want to draw triangles. So DO is equal to AR. OG is equal to congruent to RF. And BG is congruent to AF. So you can draw a triangle and write 3 angles and 3 sides. They're congruent. Today's lesson, we'd like to say we all have a proving triangle congruent tool belt. We need to supply our tool belts with tools to prove triangles are congruent. We already know that if all the sides are congruent, then all the angles are congruent, then the triangles are congruent. So all 3 angles and all 3 sides are congruent, then the triangles are congruent. We want to be able to prove triangles congruent without needing all of that information. So tool number 1, SSS. S means size. SSS means 3 sides. So this means side, side, side. This is a congruence postulate. Super important postulate that you have to know throughout the year for the test and the SOL. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then 2 triangles are congruent. That's SSS. What it looks like is this. You have 3 sides of a triangle are congruent to the 3 sides of the second triangle, then 2 triangles are congruent. So all 3 sides, this one, congruent. This one, congruent. This one, congruent. Then these 2 are congruent. You can prove that. This is called SSS, congruent postulate. Super important. So if side MN is congruent to QR, side MP is congruent to RS, and side PM is congruent to SQ, then you can conclude that triangle MNP, which is right here, is congruent to triangle QRS. This is called SSS, side, side, side postulate. Tool number 2, SAS, 2 sides and 1 angle. Side angle side is SAS, congruence postulate. If 2 sides and the included angle of the one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So here you have side, angle, side. Side, angle, side. If this happens, then you can prove mathematically that these 2 triangles are congruent. So side, angle, side. But the angle has to be between the sides. You cannot use this angle or this angle. It has to be between the 2 sides, right? Here and here. You cannot use here, here, or here, here, okay? So if side PQ is congruent to WX, angle Q is congruent to X, and side QS is congruent to XY, then triangle PQS is congruent to WXY. This is called SAS, side angle side congruent postulate. Tool number 3, ASA, 1 side and 2 angles. ASA, angle side angle congruence postulate. If 2 angles and the included side of the one triangle are congruent to 2 angles and the included side of a second triangle, then 2 triangles are congruent. what it looks like. Here you have angle, angle, and side. The side has to be between these two congruent angles. And then here, the side is between, included. So if angle A and angle D is congruent, and side AC and side DF is congruent, and C and F, angle C and F is congruent, then you can conclude that these two triangles are congruent. This is called angle side angle, ASA. ASA. Tool number 4. AAS, or you can do SAA, one side and two angles. AAS is angle side, congruence theorem. If two angles and a non-included side of the one triangle are congruent to two angles, and the corresponding non-included side of a second triangle, then two triangles are congruent. So I'm going to show you what it looks like. If angle A, angle D are congruent, angle C and angle F are congruent, then angle B and side BC and BEF is congruent, then these two are congruent. Notice that this side, BC and EF, is not in between these two. But that's okay, because if you actually have these two angles congruent to each other, we assume that this B and E is congruent to each other, because sum of a triangle is 180. So if I have these two same, then B and E is going to be same. You're going to subtract from 180 these two angles. So then B and C, this side will be congruent to each other. This side and this side. So because of the one that we did before, right? Between sides, right? So if these two are congruent, that's this one, and E and F, B, C, E, and F is going to be congruent, then they're in between. So that also will satisfy that postulate. Anyway, so if two angles are congruent, angle, and non-included side, then it is the triangle. So you can conclude that these two triangles are congruent. So we just looked at 4 tools that we have. Tools are side, SSS, SAS, side, angle, side, angle, side. This is when you prove two triangles are congruent. So you can use 4 of these tools. And then not tools, we cannot use we can only use these 4. We cannot use other ones. Okay? So there are other possible one, ASS or SSA. Those are not, you cannot use them to prove those. That's why it says no bad words. And then AAA, AAA battery, you cannot use. 3 angles, if you have 3 congruent angles, okay, you cannot prove that those are two triangles are congruent just with 3 angles. If you're gonna do that, then you gotta have 3 congruent sides. You gotta have 3 angles and 3 sides, and then they are congruent to each other. But just 3 angles, no, because one triangle can be bigger than the other lengthwise, but then the angles can be the same inside. So these two, you cannot use that to prove the triangles are congruent. Only these 4 you can use it. Okay? So let's look at example 1. Explain why triangle BCD is congruent to BFD. So we're gonna do a chart for statement and reason. First, the given is BC is congruent to BF. You see the marks here. And then DC is congruent to DF. You see the marks here. So those are given. We need to prove that these two are congruent by using SSS, side. So right here, BD is congruent to BD. That's reflexive property because they're sharing the same thing. In order to prove that these two triangles are congruent, you need to use side, side, side postulate. So you're going to write triangle BCD is congruent to triangle BFD because of side, 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 SSS postulate. Let's try example 2. Prove that this triangle and this triangle is congruent to each other. So if you look at the mark here, this and this is congruent, this one and this one is congruent, and you have an angle in between sides. What postulate is that? That postulate is SAS. So what we're going to do is we're going to prove that. So we're going to do statement and reason. So please make a chart. The given is side AE is congruent to side DE. Side BE is congruent to side CE. It's right here. This one, this one, this one, this one. That's given. Now, angle BEA and angle CED is vertical to each other. They're vertical angles. That's definition of vertical angles. And number 3, angle BEA is congruent to CED. Vertical angles are congruent. Therefore, triangle AEB, this one, and triangle DEC is side, angle, side postulate. So therefore, they are congruent because you have two sides and then angle that's including in between these two sides. And we know that how do we prove that these two angles are congruent? Because they are vertical angles. The definition of vertical angles and their vertical angles are congruent. You need to prove that these two angles are congruent in order to use SAS. Example 3. Decide whether enough information is given in the diagram to prove that this triangle is equal to this triangle. So here you have sides, and then this one they share a side. So because of reflexive property, side PR is equal to side PR. Like this side, for this triangle, they both have side PR. Because of reflexive, and you can use SSS postulate, side, side, side postulate, these two triangles can be proven to be congruent to each other. So you have to write yes, and you have to write reflexive and side, side, side. Let's take a look at example 4. Use side, side, side to prove the triangles are congruent. Here are the triangles. Now, you're going to use distance formula for one of the sides, this one and this one. You can use Pythagorean theorem too. So right here, this side is 1, 2, 3, 4, 5 units. Then this side is 1, 2, 3, 4, 5 units. This side is congruent. This right here is 1, 2, 3, 1, 2, 3. You need to prove this hypotenuse, like the slant this side. Make sure they are congruent. You can use a squared plus b squared equals c squared. Or you can use these 2 points, do distance formula. Use these 2 points. Negative 7, 0, negative 4, 5, 1, 2, and 6, 5. You can use distance formula to see if these two are also congruent. Then you can use SSS to prove that these two triangles are congruent. So go ahead and pause the video and give me the measurement of the hypotenuse. Example 5. Is it possible to prove the triangles congruent? If so, state the postulate or theorem you would use. So this one you can actually pause the video and try it, and you can check it. Pause the video and try. So this one is AAS. This one is no. This one is ASA. Because this one has no markings here, so that's why you cannot say they're congruent. You have to have markings.